Okay. Good evening, Lamai. Today we are discussing the remaining 15 questions of our monthly test paper held in last month, March. And here we have to discuss 15 MCQs, right? And yeah, we'll start from the question number 16. Okay, so this is our question number 16. Question number 16. And it is from bonding lesson. Okay. So I'll put that structure in the board and they're asking simply Lamai oxidation state and electron pair geometries of these three nitrogen atoms. Okay. I'll explain a little bit more when we are discussing the question. Right. So we have oxygen and then nitrogen, oxygen, this compound. Here nitrogen is making double bond with the adjacent nitrogen. And then this structure is there. Negative and negative. Okay. And the three nitrogen atoms are labeled as 1, 2, and 3. Okay, so these are the three nitrogen atoms. Okay, first of all, when we are finding oxidation number, okay, so I'll explain. We need to find the dipole moment. Okay, dipole moment. So when we are marking the dipole moment, we have to think about their electronegativity differences. Okay, so if you take nitrogen and oxygen, oxygen is more electronegative. That means oxygen is more likely to gain electrons. Understand? So the pair of electrons shared here is more attracted towards what? It is more attracted towards oxygen. Understood? Similarly, this one also more attracted towards oxygen because oxygen is more electronegative. So now this nitrogen, now there are two electrons in the bond now. Out of those two electrons, one is given by nitrogen, other one is given by oxygen. Right? So nitrogen is now losing two electrons partially. You can see that one with the help of two arrows. Understood? So this one, you can say nitrogen N1 lost two electrons partially. Lost two electrons partially. That is represented by the dipole moment. And Lama, you can see there is a positive charge. Okay, so because of this positive charge, you can say lost one electron totally or completely. Understood? So altogether, how many electrons are lost? It has lost 3 electrons. Okay. So if nitrogen is losing 3 electrons, then its oxidation number is going to be +3. If electron losing is there, then the oxidation number becomes positive. If electron gaining is there, then oxidation number becomes negative. Okay, so that's how it is decided. And Lamai, one important thing, here the other two bonds are made with nitrogen atoms. No? So here the two nitrogen, we call them as equally electronegative atoms, okay, because they are the atoms of same element, nitrogen. So then there is no electron exchange between them according to the oxidation number marking method. Okay, so that's why I didn't put any red color arrow. between N1 and N2 because they are same element atoms. Understood? So when a different element atom is connected to this nitrogen, then there will be a this red color arrow, which we call this red color arrow as dipole moment. Okay, I hope you remember this one and understand this one well. And this is basically how we obtain the oxidation number. So what is oxidation number? Simply, you can add that one to your review. Oxidation number is the number of electrons lost or gained totally or partially. Okay, so it's just a number of electrons lost or gained totally or partially. Here, this nitrogen lost 3 electrons at the end, right? So if you move into the second nitrogen, now if you apply the logic I earlier said, nitrogen is making bonds with other nitrogen atoms only. So there is no different element. Understand? So then the oxidation number here is going to be 0 and there is no charge also. Understand? So the oxidation number of N2 is going to be 0. No losing, no gaining. But if you go to the third nitrogen, now it is also seems like making bonds with only nitrogen atoms. So that means there are no partial electron losing or partial gaining, but there is a positive charge. So because of this positive charge, you can say lost 1 electron total. Therefore, its oxidation number becomes +1. This is how you decide their oxidation numbers. Understand, Lamai? This is how you decide their oxidation numbers by checking the oxidation number alone, without checking the other requirement, without checking the electron pair geometry. Still, you can get the correct answer. Okay, I'll show you the answers so you can understand what I'm telling here. So if you check the answers, Lamai, for the N1 +3 oxidation number is given for third and fifth answers. And then oxidation number +1 for the N3 is given for the third answer only. Understand? So the answer must be answer 3. If you want to confirm your answer, you can check electron pair geometries. Okay, so I'm going to do that too. But before that, tell me how many of you got this answer correctly? How many of you got the answer 3 for the question number 16? Okay, very good. Very good. Now, let's find out their electron pair geometries. Okay, so electron pair geometry is given by decided by number of VSCPR pairs, Vesper units. So, or in other words, we can say repulsion units. So I'm going to draw this one again and explain that part. Okay, now if you take these nitrogen bonds around the nitrogen atom and bond parts, you can see here there are 2 single bonds and 1 double bond. So double bond is considered as 1 repulsion unit. So around N1, you have 3 VSCPR units. Understand? So if you take N2, around that one, you have again another 3 VSCPR units, repulsion units. So basically, repulsion units are lone pairs and bond pairs. Okay, when you count bond pairs, we count multiple bonds as 1 repulsion unit. So in that case, around third nitrogen atom, you have only 2 repulsion units. So a triple bond and a double bond. Understand? So what are the important things you need to remember here? Lone pairs are separate repulsion units and bond pairs are separate repulsion units. But for bond pairs, single bonds, double bonds and triple bonds, we consider them as a single repulsion unit. If you have a double bond, that means it is a single repulsion unit, because double bond, there are 4 electrons in the double bond. That is true. That means there are two bonds are there, but those two bonds are not going to repel from each other. Double bonds stay as a cluster of electrons. It's a single unit. Understand? So it's not going to repel from each other. So basically, triple bond is also a single unit in that way. So if you are having such number of repulsion units, now you can decide the electron pair geometry. If you are having two repulsion units, then it is becoming linear. That means those two pairs are arranged in 180-degree angle to each other to minimize the repulsion. And if you are having three repulsion units, then it assumes trigonal planar electron pair geometry where it facilitates to keep 120 angle between repulsion units to minimize their repulsion. Okay, so trigonal planar linear is there in answer 3, so we can confirm our answer. Okay, so add a small review for this one. I explained you everything you need to know here. And let's say if you are having doubts regarding the oxidation number, you don't know about how to find oxidation number, or this concept is not that familiar to you. So then you have one option to take. Okay, what is that? Obtain the recording relevant for the oxidation number and go through that one. Or you can use your theory note also for that. Then you might not need the recording at all. Okay, so complete your review on that one. Okay. Now let's go to the question number 20, question number 17. 16 was an easy one. Okay. Question number 17 is asking, which of the following reactions has a negative enthalpy change? Okay, so there are 5 reactions given. So let's write them in the board and decide which one is negative. So what is the meaning of negative here? Negative means exothermic. If you have the paper with you, you can write negative means exothermic. Okay, so negative means exothermic. Delta H negative. Exothermic. Exothermic. Exothermic means, Lamai, heat energy is released. Heat energy is released. Okay, heat energy is released. So now let's take the reactions given. First one, sodium solid goes to sodium gas. Now, what is the name of this enthalpy change? This is called either sublimation enthalpy change, sublimation of sodium, or you can call this one as atomization. Atomization enthalpy change of sodium. And you know, state changes like sublimation require to break bonds. Okay, here you have strong metallic bonds which are need to be broken. Okay, and so breaking interactions basically require energy, and basically these physical changes, sublimation, vaporization, they all are endothermic enthalpy changes. Sublimation, vaporization, fusion, and then atomization. These are involved with the enthalpy state changes. No, atomization is involved in something else also. But my point is, they all require bond breaking. Require bond breaking, bond or attraction breaking. Therefore, it is endothermic, absorbed heat. Okay, so it's not exothermic. So answer 1 is not going to be our correct answer. Is that clear, Nami? Like that, you have to decide on it. So now let's move into the second one. Second one is O minus gains an electron to become O2 minus. So this is called, what's the name of this enthalpy change? This is delta H Eg2, second electron gain energy. Okay. So what do we know about electron gain? Okay. Only the first electron gain can be positive or either negative. Okay. Eg2, Eg3, Eg4, they all are always endothermic. Always endothermic. So why it is always endothermic? Reason. Here you have two negative charges. Two negative charges. So what will happen between two similar charges? They will repel from each other. They will repel from each other. So to overcome that repulsion, we need to supply energy. To overcome the repulsion, we must supply energy. Okay. So don't misunderstand this one with the having noble gas configuration. Hari? Now this is having the neon stable configuration NS2 NP6, that is stable, but that stability is outweighed by the repulsion. Understand? Stability is outweighed by the repulsion. Okay. Right. And if you remember about Eg1, Eg1 can be positive and both negative. That means exothermic part is there in Ag1. So what we remember is who's becoming positive. Group 2, group 18 and nitrogen. Okay. Right. And if you go to the third one, NaCl goes to NaCl solid goes to Na plus gas and Cl minus gas. So the enthalpy change, this enthalpy change is called lattice dissociation enthalpy change. Lattice dissociation. So in the name you can see dissociation is there. So to dissociate lattice or dissociate this ionic bonding you have, you need to supply energy. So it is delta H positive. Understand? And then go to the fourth one. Fourth one is N minus goes to N and electron. So to explain about this one, I'll take the reverse of this reaction. Reverse is what? N gains an electron to become N minus. Now this one is the delta H Eg1 that I mentioned here. Now can you see Eg1 for nitrogen is positive? Why? Because this is having the stable 2s2 2p3 configuration, which is stable. So it will resist to break that configuration. Understand? It will resist to break that configuration. So it is kind of we need to supply energy to do this process. Right? So this one is then positive. So if you reverse the reaction, then it must be negative. Understand? This is the reverse of this reaction. Reverse. And there is a name for this enthalpy change. This is called electron affinity. Electron affinity. It is not listed as an enthalpy change, but then the process is called electron affinity. Understood, Lama? So that is our answer. It is exothermic. So it's correct. Answer is answer 4. Okay. And the last one, fifth one, Cl minus goes to Cl and electron. This is the opposite of Eg1 of chlorine. So chlorine Eg1 is exothermic, negative. So then this is going to be positive. Understand? So then it is not a correct answer. It's a good question, by the way, kind of okay one. How many of you got answer 4? Can I see a hand raise? How many of you got? Oh, good. Answer is answer 4. Okay, answer is answer. Now write a good review for that one, especially about electron gain, electron affinity. You need to remind those points there. Okay. Yes. Okay, Pute, now we can move into the question number 18. It is from S block. It says an aqueous solution contain 2 salts of S block elements. Two salts of S block elements. The precipitate obtained by adding sodium hydroxide was filtered and dried, and no color was observed when it is examined by the flame test. Okay, in S block, you have 10 cations. Okay, you have group 1, group 2. In group 1, you have lithium, sodium, potassium, rubidium, and cesium. In group 2, you have beryllium, magnesium, calcium, strontium, and barium. These are the 10 elements. And flame test is a test that we use to distinguish these metal cations. Okay, so lithium plus, sodium plus, and there are 2 pluses. They give distinct colors. But there is a special thing. These two give no color. Okay, so if the question is telling it didn't give any color. It didn't give any color. The precipitate obtained by adding sodium hydroxide was filtered and dried out, and no color was observed when it is examined by the flame test. So that means it should be one of beryllium or magnesium. Okay, so now let's say in that solution, beryllium 2 plus or magnesium 2 plus is present on it. So what will happen when you add sodium hydroxide? It will be precipitated as beryllium hydroxide or magnesium hydroxide. And once you separate that one, and you allow it to undergo to the flame test, then it will give no color. Okay, so that's what simply happened, no? And then it tells the precipitate obtained by adding sodium sulfate. Now you are adding sodium sulfate. And that precipitate was dried and a light green color was given by the flame test. Okay, now if you examine the colors, there is only one is going to give you a green color. Okay, which is this one. You can call this one as green or yellowish green. Or there's another word, remember? Apple green. You can call any color. Basically, it is green. So then it must be barium. So what must be formed here? Barium sulfate. If you go to the solubility rules, you can remember this one there. In your solubility rules, you have magnesium sulfate, calcium sulfate, strontium sulfate, and barium sulfate. Sulfate solubility downward the group decreases. Sulfate solubility decreases. This one was soluble, well soluble compound, and this is a precipitate, a very good precipitate. You can learn more about barium sulfate under inorganic analysis also, which we are doing these days. Okay, and if you subject this one to flame test, you will give a green color. Okay, now imagine what must be the 2 cations. Either beryllium or magnesium is there, and barium must be there. Now, when you are adding sodium hydroxide, barium hydroxide will be formed, but it is not going to be a precipitate. Understand, Laman? But when you are adding sodium sulfate, barium sulfate is going to be a precipitate. Right? Barium sulfate is going to be a precipitate, but Magnesium sulfate is not a precipitate. Can you see how those things are connected? It's a very good question. Okay, it's a very good question. So because hydroxide solubility increases downward the group, sulfate solubility decreases downward the group. So it comes from solubility rules. Solubility rules, you can go and check. It is the final eighth rule. There's a table. In that table, the first and second column are there. One says solubility of sulfates decreases downward the group. That becomes barium sulfate, a very good precipitate. Other one is telling solubility of hydroxides increases downward the group. That means barium hydroxide is a very good solution. Okay, so that's how you understand this question. And the two cations are then must be magnesium 2 plus and barium 2 plus. Answer is answer 5. Okay, so there are several answers. I'll explain. If you go to the answer 1, it says beryllium and lithium. You can't take lithium no, because lithium is not going to be precipitated as a hydroxide or sulfur. Answer 2 also you can ignore about strontium. Strontium is not going to give you that green color. And sodium is not going to be a precipitate. So anyway, only answer that left is answer 5. Okay. So how many of you got answer 5? Can I see a hand raise? Okay, very good. Very good. Most of you have taken the answers. And one of our student is asking, how about the solubility of carbonates? Carbonate solubility, we don't tell it as increase or decrease downward the group. Basically, all the group 2 carbonates are precipitates. Okay, we don't compare their solubilities. Okay, all group 2 carbonates are precipitates. But so then why do we learn about sulfate and hydroxides? Ne? The reason is when you compare the sulfates, one sulfate is there soluble. That's all. And one hydroxide was there soluble, barium hydroxide. But if you take carbonates, there's nothing like that. All the carbonates are precipitates for group 2. And for carbonates, you had a separate rule in solubility rules. Refer rule number 7. It says all carbonates and phosphates are precipitates except sodium, potassium, rubidium, and cesium. Only those carbonates are and phosphates are soluble. Nothing else is going to be soluble. Understood, Dr. Laman? I hope it is enough. Answer is answer 5. Good. Most of you have taken that answer. Now let's go to the question number 19. Question number 19. It is also a somewhat good question. A2, B2 gases are connected in a rigid containers, containing rigid containers like the above. The tap was closed after opening the tap. The tap was closed after opening the tap and adding all the gas B2 into container C. The new pressure of the container C, whether there is no reaction between gases or temperature changes. So the temperature is remaining at 30 Celsius. And they says there is no reaction between A2 and B2. Asking the final pressure of C. Okay, final pressure of container C. Now container C initially it has 5 into 10 to the power 5 Pascal pressure, no? Okay, so the best method I can think of to do this one right now is this lemon. Okay, so now if you consider the C container, A2 gas, Harry, you know the volume, you know the temperature, and you know the pressure. So you know everything except moles. So if you apply PV equal nRT for C, you can find out the number of moles. And don't try to simplify, that's the secret. Don't try to simplify, just keep it as an expression. And do the same thing for D. Put PV equal nRT and keep moles as an expression. Okay, because once you open the tap and put all the B2 gas into container C, then in the C container, you will have the sum of those two moles. Understand? Sum of those two moles. Okay, then you can apply PV equal nRT again to the final container. Okay, Lamai? So now we will see how to do that question. If you put for C, PV equal nRT, PV equal nRT for C, you can say moles of A2 is equal to PV over RT. Pressure is 5 into 10 to the power 5. Volume is 4 into 10 to the power minus 3 and RT. Okay. And then if you want, you can write into 10 to the power minus 3, but no point, it is going to be cancelled anyway. And if you consider for D container, the moles of B2 is equal to 8 into 10 to the power 5 into 2 into 10 to the power minus 3 decimeter cube volume and RT. So I am keeping writing RT like this, no point of writing the temperature also. Why? It is again same throughout the whole procedure. Right? Now these are the moles. Now the new situation. In new situation, you have everything contained in bulb C. Okay, and again now for C, we can apply P equal nRT over V. Okay, P equal nRT over V. So N is simply the addition of these two. 5 into 10 to the power minus 10 to the power 5 into 4 into 10 to the power minus 3 plus 8 into 10 to the power 5 into 2 into 10 to the power minus 3. And RT is the common denominator. This is the number of moles. And then you are multiplying that one by RT again. RT is still not changing. And the new volume of new volume now is 4. Okay, so if you simplify it properly, you can cut this RT. And yeah, this gives you 5 into 4, 20. Or just cut the minus 3 also. It's easier then. And yeah, you can cut this 4 also. I'll just write it again, otherwise you will get confused. So you can cut now from 4 also. So it's 5 into 10 to the power 5 plus 2 times 2 is 4. 4 into 10 to the power 5. 4 into 10 to the power 5. So it will give you 9 into 10 to the power 5 Pascal. There may be other methods you can try this one. But you know, any method is okay. You are getting the correct answer. Understood, Laman? Find the moles, then substitute. Okay, it's nothing difficult, Pude. Apply PV equal nRT for the C container and find the moles of A2. Find the moles of B2 from D container. And then, according to the question, it says all the gases are now included in C container. And for C container, apply PV equal nRT again. Okay, so that's the method. Sabri, you understand that one now? Okay. Now let's go to the question number 20. Question number 20. What is the temperature change occurring when 100 centimeter cube of 1 mole per decimeter cube sodium hydroxide solution were mixed with 100 centimeter cube of HCl solution at the same concentration in a thermally insulated container. Okay, thermally insulated container. So they're asking the temperature change. Now, they have given the enthalpy change of neutralization. They have given you the enthalpy change of neutralization. That means how much energy is released when 1 mole is reacting. Okay, so it says minus 57 kilojoules per mole. So the simple idea is, Lamai, neutralization enthalpy is like this. H plus OH minus gives you H2O liquid. If 1 mole of H plus reacts with 1 mole of OH minus, you will have 1 mole of water. When 1 mole of water is producing, when 1 mole of H2O is produced, 57 kilojoules of heat is released. This is the simple meaning of this enthalpy value. Okay, Putri? This is the simple meaning of this enthalpy value. And yeah, now see how many moles of sodium hydroxide then HCl are reacting. Gives you NaCl and 1 water molecule. So that means their molar ratios are 1:1:1. Okay. So now number of moles of this one, since the volume and concentrations are equal, moles of sodium hydroxide is equal to 1 mole per decimeter cube into 100 centimeter cube. That means 0.1 decimeter cube. Okay. And then you will get 0.1 moles. 0.1 moles. And now let's say if 0.1 mole of this one is reacting with 0.1 mole of this one, you will get 0.1 mole of water. That means for 1 mole of water, if you get 57 kilojoules, for 0.1 mole of water, you should get 5.7 kilojoules. That's the heat released. Okay, heat released. Now, we are ready to apply Q equal MC delta T to find the temperature change. So, temperature change is equal to Q divided by MC. Now, Q is 5.7 into 10 to the power 3 joules. Mass here, now the mass is actually the mass participated in heat exchange. Okay, here the solution. So you have 0.1 decimeter and 0.1 decimeter. We can say 100 plus 100 centimeter cube. So 200 centimeter cube. 200 centimeter cube is there. Okay. So basically if you multiply that one by mass, so density into volume. So it's 200 grams. Thus the density is 1 gram per centimeter cube. 200 grams. Okay. So 200 grams into specific heat capacity is given 4.2 joule per gram per Kelvin. Now you can see everything get cancelled and only you will get the answer in Kelvin. Okay. So 8.4 57 divided by 8.4. Okay, so 56 you have kind of 7 eighths. Now it is somewhere around 6 point something. Yeah, the answer is answer 4, 6.8 Kelvin, or you can say that if you take the difference, delta T is 6.8 Celsius. So this T is the capital delta T, what we are getting, as we get the answer in Kelvin. Understood, Lam? If you want to simplify it, you can get the answer. Should be 6 point something. Okay. And I hope it is clear to you up to the 20th question. Now let's move into the question number 21. Yeah, we add the both volumes. That's what we did, ne? 100 centimeter cube and 100 centimeter cube. 200 centimeter cube. Okay, na? We did that one, ne? While finding the total mass, we did it. Is that okay? Clear? But when we are finding the moles of one substance, we are considering the volume of that only. Let's say I want to find moles of sodium hydroxide. I should consider the volume of sodium hydroxide only, nothing else. In that case, don't try to get the total volume. Okay, now we are coming to the ABCD questions. Look at the first one. Which of the following statements is correct with regard to 3D block elements and their compounds? First one says, among 3D block elements, scandium is not considered as a transition element. Okay, that is wrong. Scandium is a transition element. So you can see, right, you can write in front of that. The only non-transition element from 3D series is zinc. Only non-transition element from 3D series is zinc. A is wrong. Only non-transition from 3D series is zinc. Okay, others are transition. And you can write the transition definition also. So what are transition metals? What is the definition? They have either, so they have incompletely filled d sub energy level or d sub shell in element or in ionic states. Okay, in element or in ionic states. Understood? So that is the transition definition. So A is wrong. What about B? The radii of atoms scandium to copper decreases from left to right. It's also wrong today. The radius is actually decreases, then it slightly increases. To start from scandium, it decreases up to cobalt. And cobalt and nickel are having basically the same atomic radius. But after that, it slightly increases. Copper and zinc are having kind of higher radii than cobalt and nickel. But it is not higher than scandium. Just understand that. So telling it is decreasing up to copper is wrong. It is not decreasing up to copper. And look at the statement C. The colors of the two complexes. Nickel amine complex is blue. Sometimes this is referred as deep blue also. And the other amine complex is zinc. Zinc amine complex is colorless. Okay, so why zinc amine complex is colorless? You can write that one. Why zinc 2 plus complexes are colorless? Colorless. Okay, so given color, it should have incompletely filled d sub energy levels. That's the problem. Okay, so zinc 2 plus, no unpaired d electrons. That's the problem. Okay, that's why it is colorless. Write that reason. Good to know. And the last one, the IUPAC name, K2 nickel and Cl4. No need to write the square bracket in for simple compounds like this. This is wrong, Pute, because it starts by telling dipotassium. There is no dipotassium. So the counter cation, we write it simply like saying potassium. Potassium space tetrachloride, nickelate 2. This is the IUPAC name. There's another mistake. It says tetrachloro. That is also a mistake. It should be tetrachloride. Understand? Tetrachloride. So only one statement is correct. So therefore, answer is going to be answer 5. Answer is going to be answer 5. Now, our student is asking about the earlier question. Question number 19. She's asking whether we should add the volume of two bulbs, C and D. No. Look at the bolded statement. They're adding all the B2 gas into container C. Read it properly. We are not going to add the total volume. We have done questions like that, but this particular question, the final volume is 4 decimeter cube. Okay, read it carefully. Right. Now shall we go to the question number 22? It is another past paper question I selected to ask. Question number 22. In 22, it is telling which of the following statements are true regarding the S and P block elements? Okay, so beryllium reacts with hydrogen gas to produce an ionic metal hydride. It is wrong. Okay, so there are two mistakes here. Okay, so first one is beryllium reacts. That is wrong. Okay, so beryllium does not react. Does not react with H2. That is the first mistake. And the next thing is, but you can form beryllium hydride by reacting other species, but not a direct reaction, but let's say you are reacting beryllium containing salt with a hydrogen containing another compound. So then they will form beryllium hydride, but not by the direct reaction. So once they formed beryllium hydride in some way, this is not an ionic hydride, this is a covalent hydride. Okay, so there are two mistakes in the statement A. And if you go to the B, it says magnesium has the highest electronegativity among S block elements. So remember, from group 1 and group 2 is having the higher electronegativity. And if you take lithium and beryllium is the one with higher electronegativity. Highest En from S block. And lithium is the highest En electronegativity from group 1. From group 1. So this is wrong. What about C? Ammonia, carbon dioxide, ammonia, SO2 and H2S can act as an oxidizing agent as well as a reducing agent. Okay, so anyway, this statement is not explained yet, but this is a correct statement. But I gave the answer as answer 5 because this statement was not taught in the class yet. So anyway, oxidizing and reducing agent, they can act as oxidizing and reducing agents. You can write it until we learn it under the P block. Shall we write? NH3 can undergo oxidation and become N2 gas, and can undergo reduction and become H2 gas. To take H2S, it follows the same procedure: oxidize to give sulfur, reduce to give H2. Okay, so this is oxidation, this is reduction. And the final SO2 oxidize to give SO4 minus, reduce to give sulfur. Okay, you will learn this one under P block. And here in these cases, they are acting as reducing agents. Reducing agents. Okay, then other side, while they are reducing, they act as oxidizing agents. Okay, but anyway, this was not expected in your paper. Last statement is sodium and barium react with excess oxygen to give Na2O2 and BaO2. Sodium reacts with oxygen to give sodium oxide, and with excess O2, the main product is sodium peroxide. It is the major product. Okay, so both are formed, but Na2O2 is the major product. So they are telling this one is formed. They are not telling this is only formed. හරි දැන් මේක විතරක් හැදෙනවා කියන්නේ this is and sodium peroxide is formed, so that is correct. And second part is barium. Barium is also capable of making peroxide, BaO and BaO2. This is oxide, which is the main product, and this is the peroxide, but that peroxide is also formed. Okay, they are not telling peroxide is the main product or anything. So then that statement is correct. So if you properly understood the question for A-level exam, answer should be answer CD, answer 3. But since I didn't teach you this part yet, I gave you answer 5 also, because if someone selected this as wrong, he or she will end up with the answer 5. Okay, Bude? That is the idea. Okay, I hope it is clear for the question number 22. Okay, now the question number 23, kind of an easy question part. 23 says, which of the following statements is true? Positive rays formed by eliminating an electron from an atom or a molecule inside a cathode ray tube. That is true. That's how basically positive rays are formed. Or anode rays are formed. Since it is needed for both the statements 1 and 2, A and B, I'll explain that here. Okay. So this is our cathode ray tube. In our cathode ray tube, from cathode to anode, electrons are moving. So when these electrons are moving, they can collide with existing gaseous molecules. Let's say it is colliding with a hydrogen molecule, H2. Then what will happen? That H2 will be dissociated to 2H or H plus H with the energy of that electron. And if the electrons are further colliding on this H atom, it will be ionized to H plus. Okay, and there's another thing happen. I think I didn't mention this one to you earlier. If H2 can directly form ions also, this is also possible. Right? This is also possible because without dissociating, ions can form. But it's a rare case, but it is possible. Now, these are the two types of positive compounds, positive species that are formed. Now, these positive species, what will happen? They are attracted towards the negative cathode. But if you keep a hole or perforation in the cathode, what will happen? They will move through the perforation and go behind the anode, behind the cathode. Understand? And that is what we call as positive rays. But as you can see, positive rays are not originating from the anode. Okay. So according to that explanation, A is correct. A is correct. and B is wrong. Okay. And positive rays are not affected by electric and magnetic field. That is also wrong. Basically, simply any charged particle, change the path or deflect in electrical and magnetic fields. Electrical and magnetic fields. They change the path in electrical and magnetic fields. Okay, Pudit? So C is wrong. What about the last statement? It says cathode rays originate from cathode. That is true. You can understand electrons are basically coming from the negative terminal of the cell, and it is jumping away from the cathode. So cathode rays are originating from the cathode, but anode rays are not originating from the anode. Okay, so that's the explanation for question number 23. So how many of you got that answer correct? They're asking the correct answer. Answer 4. How many of you got answer 4? No, very good. Now let's go to the next question. Question number 24. It is a chemical calculation question. See, says 60 grams of magnesium is allowed to react with 30 grams of nitrogen. So anyway, this reaction gives you magnesium nitride. If you balance it, you have to put 3 in front of magnesium. So they are reacting in 3:1 ratio. Okay. So it says about 60 grams of magnesium. Sorry, 30 grams of, no, 60 grams of magnesium. So moles of magnesium you can find by dividing 60 from its relative atomic mass 24. Okay. So then you can simplify that one. You can see it is divisible. And yeah, or you can keep it in this way. Or you can simplify anything you prefer. Right? So anyway, if you divided this one by 12, you have 2 and 5. So it is 2.5 moles. And then you can find out moles of nitrogen also. Now they are given data regarding 2 reactants. It is N2. So it should be 28, not 14. So you will get 1 point something. 1 point something. Okay. So anyway, Lamai, since you are given data regarding 2 reactants, you need to consider this question as a limiting reactant question. In a limiting reactant question, we are applying ARR method and going to find which reactant has fully consumed. Okay, right. So let's apply ARR method and see added reactant remaining. So 2.5 is here, and here more than 1. That means 30 divided by 28 is here. Now, Lamai, to react with 1, you need 3, but you don't have 3, no? You have only 2.5. So that means this is our limiting reactant. So understand, it is not enough. It is not enough. To react with 1 and 2, you have to have 3 magnesium, but you don't have that amount. Because here you have 1 point something around 1, but that means we should have more than 3. Should have more than 3. But you don't have at least 3. Okay? So it's going to be the limiting reactant. So this is going to be fully consumed. And 2.5 divided by 3 is going to be consumed from here. And 2.5 divided by 3 is going to be formed from here. And here it is nothing remaining. And there will be some amount remaining from here, which we no need to calculate. 2.5 divided by. Okay, now let's go to the statements and see. It says in the complete reaction, magnesium is the limiting reactant, A is true. And says N2 is the limiting reactant, B is wrong. The product will be, look at the product, MgN2, that's wrong. Mg3N2, that's the correct product. And theoretically, the amount of product formed will be 83.3. So to find theoretical amount produced, what you should do, into mass of Mg3N2, multiply the moles by molar mass. So what is the molar mass of this compound? 24 times 3 gives you 72. 72 plus 28. Okay, it's 100. 100 grams per mole. So once you multiply 25 divided by 3 into 100. Okay, so you will get that mass. You will get that mass. So it's 250 divided by 3. Let's see. 8 point. Wait. $83 point. 83.3 grams. Ne? Theoretically, amount of product formed will be 83.3 grams. That is correct, no? Yeah, I have marked it as wrong. Sorry. Anyway, this one is correct. So answer is going to be answer 4. Okay, Puti? So how many of you got answer 4 for this question? Answer 4? Very good. Very good. Okay. Right, now let's go to the question number 25. So it's a limiting reactant question we completed. Okay? And question number 25 is asking about the molecular kinetic theory of gases. Okay, so look at the first statement. It says gaseous molecules are very small, hence their mass is neglected. It is wrong. We neglect something, but it is not mass. Ne? So what do we neglect? We neglect the volume. Okay, so A and A is wrong, but B is correct. Okay, question number 25. A is wrong. We don't neglect the mass. We neglect the volume. We neglect the volume. And look at the statement. See, collisions among gaseous molecules are perfectly elastic. Okay. So gaseous molecules, their collisions are perfectly elastic. That is also correct. And last one, at a given temperature, kinetic energies of all gaseous molecules are same. It is wrong, Pute. They are in a Boltzmann distribution. Okay, kinetic energies of gas molecules are in a Boltzmann distribution. That means they are like this. This is energy, or you can say speed. And this is the fraction of molecules. Okay, can you see? The most probable speed or most probable kinetic energy is there. And they don't have, or they all not have the same energy. So that is wrong. But anyway, they are asking the wrong ones. Incorrect one. So answer is answer 4. Incorrect. Okay. So say for the last statement, energy of gas molecules are not the same. There is a Boltzmann distribution. Different gas molecules may have different kinetics energies. Okay, now we are coming to the last 5 questions. True, false questions. "26. The critical temperature of ammonia gas is greater than the critical temperature of carbon dioxide gas." Okay, so what is this critical temperature? So if you take this phase diagram, so this is solid, this is liquid, this is gas. So critical point is this one, and this is the critical temperature. Okay, so the thing is, Lamai, the liquid gas equilibrium is existing up to critical point. After critical point, you don't have that equilibrium. So if you have a gas, let's say at T temperature, T1 temperature, if you compress that gas, you can make it into a liquid, no problem. Right? The compression will bring you a liquid. But if it is there at, let's say, T2 temperature, the more you compress, no matter how much you compress, you will not get a liquid. Okay, so what you will get is a highly compressed gas. Highly compressed gas. So which we call as supercritical fluid. Remember? Supercritical fluid. So T1 is giving you a liquid, but at T2 you are not given a liquid. Right? So that is what meant by the critical temperature. And critical temperature is depending on the attraction forces. If let's say there is a molecule, ammonia, the one given here, is a gas that can form hydrogen bonds. So ammonia at a higher pressure, even at a higher temperature, ammonia can make good interactions because hydrogen bond is a good interaction. So critical temperature of ammonia will be higher. But take to the other hand carbon dioxide, a non-polar molecule. Its intermolecular interactions are weak. So at even at a lower temperature, their attraction forces will be anyway weak. So it's kind of difficult to compress and liquefy. Understand? So it depends on the attraction forces. Okay, so today remember, if intermolecular attractions are powerful, critical temperature is higher. So now this says ammonia has a greater critical temperature. First statement is correct. And second one tells ammonia is having stronger intermolecular attraction. That is correct. And it can explain the first one. Okay, Putri, so your answer is answer 1. Okay, how many of you got answer 1 for that question? It's a good question. How many of you got the answer 1? No. Okay, very good. Okay, let me others remember this one. Okay? If intermolecular attractions are better, then critical temperature is higher. "27. ICl4 minus is iron is a tetrahedral ion. If you take ICl4 minus, It is a square plane molecule. And the minus charge is there. Says it is tetrahedral is wrong. First one is wrong. You can say it is square plane shape octahedral geometry. Okay, what about the second step? There are 6 repulsion units around the iodine atom. Yeah, there are 6 repulsion units. That is correct. You have 2 lone pairs, and then you have 2 bond pairs. Sorry, 4 bond pairs. Altogether, you have 6 BSCPR units. That is correct. Okay, now. So answer is answer 4. Answer is answer 4. Go to the next question. Question number 28. An electronegativity of manganese is lower than the electronegativity of chromium and Fe iron. Now this is checking electronegativity of D block compound, metals, right? And for each property like that, we have a separate shape to remember. Remember, for the electronegativity, we have this particular shape. This particular shape. Potassium, calcium, scandium. Then we have from here to here, chromium, manganese, iron. Then you have cobalt, nickel, sun is copper, and then you have zinc. Understand? So these are the electronegativity comparisons. So now telling manganese is having a lower value than the adjacent 2 metals is correct. So first statement is correct. And why is that? Because it is having 3D5 4s2 stable electronic configuration. So when it is having a stable electronic configuration, the tendency to gain electrons is low. What is electronegativity? Simply ability to gain electrons from a bond. If it is having a stable configuration, that ability is low. Understood? So electronic configuration is more stable. So that second statement is correct. It can explain the first statement. Answer is going to be answer 1. How many of you got answer 1 for the question number 28? Okay. Yeah, so one doubt is there regarding question number 27. They haven't mentioned the shape, but still tetrahedral is not going to be a shape or an electron pair geometry. For ICL4 minus clearly. So anyway, we are taking it as wrong. Understood? Tetrahedral means either shape or geometry. Electron pair geometry. Okay, go to the question number 29. This is a good question. Remember Cr2O3. If you take these D block oxides, so I'll write about chromium, CrO, Cr2O3, CrO2, and CrO3 like that. For chromium, there are 4 oxides. For the oxidation numbers +2, +3, +4, and +6. So I gave you a method to remember how to do this one. Now this one is amphoteric. And this is basic, and this is weakly acidic, and this one is acidic. That's how their acidity basicities are given. So what is meant by amphoteric? Amphoteric means reactive both react with both acids and bases. Okay. So now telling this one is amphoteric is correct. And second one, it shows acidic character is also correct. Understood? And it shows basic character as well, but it can't explain the amphoteric nature. Understand? Actually, you can't explain amphoteric nature according to A-level facts. Okay. So answer is answer 2. It's not going to explain. So how many of you got answer 2 for this one? Okay. Good. Now let's go to the last question. Sub 30 says sublimation, fusion, vaporization are always positive. I think I wrote it earlier also. That is correct. They are endothermic. Endothermic. That means we must supply energy to do those changes. We need to break the attractions thing. Second one says heat is absorbed to weaken the attractions. That's correct. Explains also. Answer is answer 1. So how many of you got answer 1 for that question? Question number 30. Very good. Very good. And Lama, your marks will be given within this week. Okay, this Thursday, Saturday, and next Monday. Your marks will be given. And get prepared for the April test. I'll inform you the date. Probably it will be kept in the last week. I'll inform you the date. And study and write a good review for these MCQs. Okay, now like this, the MCQ discussion ends. And write your review and bring it to the class. Okay, for a while I couldn't check your reviews. Right now, after finishing the 30 MCQ review, okay, bring it and then we can mark it now. Right? So study well, Amai, and like I said, get prepared for our next exam this month. I'll tell you the exam structure and question structure before the exam. Okay, right, Lamai? So good night, everyone. Study well. If you have any further doubts, please send them to my WhatsApp.